I'm going to show you the recap of section 4.1 where we learned about similarity and proportions. Similarity is when figures are the same, but they could be a different size. One example of that is these two triangles. They look the same, however, if you look closely at the side lengths and compare them, you'll recognize that one is twice the size of the other. We can specifically identify similarity by looking at corresponding sides and seeing if they are proportionate. Proportionate means that they have equal proportions or fractions when we compare them. Let's take a look at an example of how to check proportions. So here I have two triangles. They are labeled. We can see one is definitely bigger than the other, and I'm just going to label one as triangle A. I'm going to label the other as triangle B. That way we can just distinguish between the two. So first thing you want to do is pick some corresponding sides to compare. Corresponding means they're in the same position. And as you can see here, I've got these two side lengths that are in the same position. These ones I highlighted in yellow, the 3 and the 6, those are corresponding. And we also see they're across from the angle, so they're in the same spot. Now we're going to write them as a fraction. So I'm going to pick the side of A over the side of B. And again, this is those yellow sides, those corresponding sides. So the side of A is here, and then the side of B is over here as 6. 3 over 6. I'm just going to highlight this too. All right. Next step is to reduce the fraction. So we have 3/6. We want to reduce it as much as we can. And if I divide both of them by 3, I see I can get 1/2, and that is the most reduced. So the proportion here from one triangle to the other is 1/2. That's what we're looking for. That's how you can check the proportion. Last thing you want to do is repeat the same step, but with the other side. So we only compared one. You want to make sure you compare all of them. Let's see an example where we check the proportions to show similarity. So I have these two triangles here. I have triangle A, triangle B, and I'm noticing one looks a little bigger than the other. The side lengths are definitely different. So let's just start by comparing sides. So I'm going to pick a pair of corresponding sides here. I'll use pink. So this one goes with this one. So the 2 goes with the 4. Those are in the same position. Those are corresponding. So I'm just going to write a fraction. The side of A over that side of B. And it's those pink sections there. And so that equals 2 over 4. And again, those come directly from those sides of the triangle. And if I reduce it, I get 1/2. Now we're going to repeat. We're going to pick a different set of sides to do this with. So we'll pick the side 4, and that's going to go with, the 4 goes with which one? 4 goes with the 8. So I'm going to compare that side of A to the orange side of B. And that's going to equal 4 over 8. Reduce that, and we get 1/2 again. That's good. We're wanting to get the same proportions. That's the goal here, to prove similarity. Last one we need to check the proportion of is this side, comparing 3 to 6. The 3 is the side of A, the 6 is the side of B. So 3 over 6, and that again equals 1/2. That's great. That is exactly what we want to see. In order to show similarity between triangles or any figure, you need to show that that proportion is consistent, or that it is the same, or that it is proportionate. You want equal proportions. So therefore, these are similar. It's important to notice and point this out at the end. Even if you do all the math correctly, you need to say, yes, they are similar. All right, let's move on to an example. So in this example, it looks a little different than the one before, because if you notice here, we do have the triangle A and B. They are different numbers, but there's missing, we're missing a side here. We're missing a side length, X. So we need to figure out what X is, and we're given that they are similar. And remember, similar means that the proportions are equal. So we have that fun fact. We already know the proportions are equal. And we can use that now to figure out what X is. So let's go ahead and compare the proportions. We're going to compare the proportions. We're going to compare them with an equal sign because we know that they are equal. All right, so we're just going to pick some sides. We're definitely going to use the green ones, the 8 and the x, because we're trying to figure out what x is. So I'm just going to write that side of A over that side of B. And we know that the side of A is 8. It's the green one up there. And the side of B is x. And now we need to figure out a different side. We could use the 12 and the 18, or we could use the 15 and the 10. Yellow or blue, it doesn't matter as long as we're consistent with it. I'm going to go with blue, with the 10 and the 15. So we need the blue side of the A triangle, and then we also need it for the B triangle. And notice I have A on the top and B on the bottom for the green and the blue here. You want to be consistent. So the side of A is 10, the side of B is 15. So 10 over 15. Okay, so I've got an equation set up with a couple fractions. We need to solve for x. So I have 8 over x equals 10 over 15. And the way we do this, you might remember this from another math class. It's called cross multiplication, or we're going to cross multiply. So I'm just going to put this in a little thought bubble here. We're going to cross multiply. That's how we're going to solve. And the way we cross multiply is we are going to multiply and connect them across the equal sign. So the 8 goes with the 15, the 10 goes with the x, and we connect them through multiplication. So 8 times 15 equals 10 times x. And I'm just going to clean this up a little bit. So 8 times 15, that's 120. And then 10 times x, well, that's just 10x. To solve for x, divide both sides by 10, and we get x equals 12. And that is the answer. We just solved for the missing side. The missing side was 12.